We'll start with logistic regression. See, as yesterday I told you, 80% of the steps, or I will say up to 80 to 85% of the steps in any machine learning analysis are the same. They are the same. So can anybody want to guess what this, in just one or two words, can you they tell what these steps are which are common in every machine learning analysis?
So first thing is we explore the data and do some visual
right
things to see how the data is behaving against each input parameter.
Right, very nice. Then next step.
And then we go ahead and decide what kind of model we.
No. Model is another step. In between, there is one important step you are missing.
Data cleaning, data parsing.
Yes, Ravi,
null
sir,
value
exactly.
filtering.
Yes, exactly. So exploratory data analysis, or EDA, what we call, or the data cleaning or data pre-processing, what we call is, as Ravi sir said, are the most common processes in almost all the machine learning analysis. And they form up to 80 to 85% of our total project time, and include in that the data collection time. So data collection time, if you include, then 90% of your effort is data collection, exploratory data analysis, and data pre-processing. Data pre-processing means data cleaning. First, you have to clean the data. You have to reformat it to your whatever format you want to see it. You have to format in that format. Then you have to do some missing value treatment if any lot of missing values are there. So appropriate treatment has to be done for that. Then there will be outliers in numerical variables. Yeah, categorical value. Then there will be outliers in that. So the outlier treatment should be done. So that all kind of treatment should be done. So that is all. This is data formatting, data cleaning, and missing value treatment, outlier treatment. This all comes under the category of data pre-processing. So data pre-processing and exploratory data analysis pretty much forms, I will say, up to 90% of your project effort. So, and for this data pre-processing and data cleaning, that's where you need Python code. That's where you need your Python. So in doing this, you have to write some Python code, which will not be available in your libraries, because for every data set, these steps will be different. Different kind of cleaning will be required, different kind of pre-processing will be required, different kind of formatting will be required. So you have to write custom format code. Always you will be writing a custom, always you will be writing custom format code for these steps. Okay, so that's where you need some expertise in Python. And another 10% part is model building, rebuilding, testing, rebuilding, then testing, rebuilding, and then testing. So with that, your machine learning project will be done till model building. And after that, operation steps will come, like evaluation of the model, then testing by business, then deployment, and then whatever we call ML operations, machine learning operations. Like you have, so like your software operations group is there, like we have machine learning operations also. So that is entirely a different line, which is still under development. Like with that, this knowledge or this practice of machine learning operations is not yet fully developed. It is evolving. It is coming up. Okay, so that then those steps will start. Then every year you have to reevaluate your model. Every 6 months you will reevaluate the model, recalibrate it, and if it is gone off the way, then you have to rebuild the model, redeploy it. Then after 6 months again you will calibrate it. So it is called model maintenance. So model maintenance and putting up into production. So it is something related to machine learning operations. Okay, so these are the steps, basic steps. And is any operation means any continuous thing, right? Project means it has a definite start and definite end. Project is there, definite start and end. And operations means it is continuous. All the time it will be running. So ML operations is something which is a continuous process. Okay. So in our classes here, we'll not get into ML operations. That is a different line of study, and that is an evolving field. So steps vary a lot depending upon the company. Every company is following its own step in ML operations. But till model development, more or less, nice evolution has been done, and processes are almost same in every company. So it is data collection number one, then data exploratory data analysis and data pre-processing. These are pretty much the same for every company. That every company does it. And before model development, that takes up to 90% of our total time till model development. After that, ML operations is a separate time, right? So now today we are getting into binary logistic regression. So binary logistic regression we are getting into. So we have only two classes, 0 and 1, and they are dependent on multiple variables. So it's a multivariate binary logistic regression. Okay, so that's what we are taking up today. So we'll come to the data set. First, let us say usual imports. Import NumPy, import pandas, import matplotlib, import seaborn, and we do this percent matplotlib inline. We write this customary piece of code. It should be there in every Jupyter notebook or every Python code. This code should be there. Whatever figures you draw with the help of seaborn or matplotlib, we want to see that in the same, the output will be same, the same Jupyter notebook. So that's why we write this kind of code. And these people write this code. This is a piece of code, Python code, which people write to just list the directory. Which files are there in the directory. So for that, this Python will not get into details. It will just list which files are there in the directory. We will assume that we know our directory and we know our data file also. Okay. So now this piece of code, I think you are familiar. Import warnings dot filter warnings ignore. That means whatever inline warnings Python is throwing while executing. So as we get output, so Python will throw some warnings. So they are unnecessarily annoying warnings. So we don't want those warnings. That's why we write this piece of code to suppress the warnings. Okay. Now our data file is weatheraustralia.csv. So it is related to weather data and it is related to Australia. And why I have not given path here? Because my file is in the same directory as my code file. So my code file and my data file are in the same directory. If they are in the same directory, then I need not give the path. It automatically picks up. I say read underscore CSV, convert it to a Python data frame. Everyone knows this. Then we see the data shape. It is a huge database file, around 1,42,193 rows and 24 columns. So it's a huge file by any standard. We see the head. Just want to get a feel of it. So we just see the head means see the important columns. So it is all geographical data and weather data. So the first column is a date column, on which date it was taken. Then you have location, which location. Then you have minimum temperature, maximum temperature, rainfall, evaporation, sunshine, wind gust direction, all meteorological data. Wind gust speed, wind speed at 9 p.m. There are so many other columns. Plus you have humidity at 3 p.m. So pressure at 9 p.m., pressure at 3 p.m., clouds, there is some measure for cloud also. So they are representing it by numbers. So cloud at 9 a.m., cloud at 3 p.m. It's a very comprehensive weather data. See temperature at 9 a.m., temperature at 9 p.m., rain, whether there was rain today or not. Then risk, I suppose this is a risk of getting precipitation. Then rain tomorrow. So that's what is our y variable. Rain tomorrow is our y variable. Rain tomorrow is our y variable. Okay, so this is our target variable. So based on all these variable, left-hand side variable, we have to predict whether it is going to rain tomorrow, yes or no. That is our job. And to train our data set, we have around 1,42,000 rows here. 1,42,000 rows available here, for which we know whether it rained or not. So we already have historical data. For so much historical data we have for a lot of locations. See, there is for multiple locations. See, locations right now you see Albury, but I suppose there are multiple locations here. So multiple locations are there. And for multiple locations, we have weather data collected in an observatory, very professionally collected in an observatory. And then you have to predict whether there will be rain tomorrow. You have historical data, around 1,41,000 rows for historical data you have. With that help, you have to train your logistic regression data set. And once your model is trained, then some unseen data of today will be given to you. Today, whether you will not know whether tomorrow it is going to rain or not. So based on that model, you have to tell whether tomorrow it will be rain, yes or no. That will be your job, weather prediction. Right? Weather prediction is our job here. So weather means only rain. Okay. So with df.columns, we are listing only columns here. So there are 25 columns as we read there. Then this risk mm is a variable which this kind of he's dropping risk mm variable. This underscore mm. Why we are dropping? Such kind of decisions are given by business experts. Such kind of decisions are business experts. So our weather scientist told us that this risk mm has nothing to do with whether tomorrow it will rain or not. If whether it will rain tomorrow, it will rain or not tomorrow, the risk MM has nothing to take with this data, so we are dropping. It is not useful column for us. So we are dropping x is equal to 1 because x is, we are dropping a column, so x is equal to 1, in place equal to true, because in the same code without equating to anything, in the same df itself, we want to replace it. Otherwise, if we don't put in place equal to true, we have then we have to give a different treatment. We have to equate it to another data set. Then only we can see our change. But if you do like this, in place equal to true, that means same place, right? The same code itself, this risk mm column will be permanently deleted. So we see the information of the data set, information on the data set. So you see that date is expressed as an object. Date is date column is expressed as object type. So we have to convert it into object. We have to convert into date and column letter. Location is a string, which is again given. Location is a string data, right? Location is the name of the place, so it is string data. So it is expressed in object type. So that also we have to convert into strings. Race columns are very easy, like race are all float only. This weather direction also given as object, we have to convert in string. Weather direction, again we have to convert it into string. Race or float is a real number. And then rain today, yes or no. So this is also binary data, yes or no. So that also we have to convert. And then rain tomorrow, that is our target variable. So this is how complete description of data set we get. And we have around 1,42,000, 193 rows and 23 columns. We had 24, one we dropped, so it remained 23. Okay, so type of variables. So first of all, we want to check. We have both. See, if you see here, we have both variables. Float, object. Float and object, two type of variables are there. So it is, you get a float 16 and object type of variable, we have 7. So first, all categorical variables, they have put it as in the original data set, they have described as object. So we are separating categorical data, categorical variable we are separating with a simple line of code, and data type, we are equating data type as O. O means object. And we are saving it into one categorical variable. And when we print it, then we see that there are 7 categorical variables of object type, and these are the 7 categorical variables. So you see, in the date also is coming as a categorical variable. So we have to convert it later on. Rest all are string type of variables. Rest all which I am highlighting are string type of variables. Only date we have to give separate treatment. That we'll see later. Now we are listing only the categorical columns here, DF categorical only from this data frame. Only categorical columns we are listing, so nothing great in that. So then we go to missing values. So we want to check, we always want to check missing values, right? So first we are treating categorical values, whether missing values are there. So is null means it is telling whether missing value is there, yes or no, and sum means we're summing up. So if we do this sum on this is null means all the all the rows will null, all the rows with null will be summed up. So we see that location is having no missing value. Wind gust direction is 9,930. Then wind direction 9 am and 10,000. Like that, we have listed categorical variables. How many missing rows are there in these columns? Rain tomorrow is not having any missing columns. Okay. Then we are printing these two columns. We are removing, who are not having missing, because they are already good for us. We don't want to treat them. Location and rent tomorrow. So only these are the only 4 columns which are having missing values. Okay. Then we want to find out the frequency of categorical variables. So value counts we have done. So I think everybody must be everybody should be aware about the value counts. It will count the distinct values. So see, which we are counting, or we are taking 6 categorical variables, and we are counting there how many unique values are there. So you see here, first column is date. So date is, these many dates are this 27/0/27, which I have highlighted, is repeated 49 times. So like that, date later. The next one is our next one, column name it gives below. So I think these are place names, location. Yes, it is location. So you see last location Uluru. Last location Uluru is repeated 1,521 times. So like that, the frequency for all the categorical columns is listed here. Nothing great. So only good thing about this code is that only good thing about that code I want to tell you is that in one shot we have listed frequencies of all the categorical columns in one shot itself, instead of counting in place of applying value counts to individual columns. In one shot, in one for loop, we have listed for all the variable columns, all the categorical columns. So that is then we see the frequency of percentage, frequency of distribution of categorical variables. What we have done? Value counts, individual frequency, numerator is nothing but, this numerator is nothing but it is individual frequency. And this is total column length, around 14,000, 1,41,000, 42,000, whatever. So this is total column length, and this is individual frequency of individual string. So this is the percentage we will get as percentage. Same thing is coming up as percentage. So it is nothing but exploratory data analysis. Okay, it is exploratory data analysis. It is exploring the data. Now, number of labels, we call it cardinality. Little bit if you read about type of categorical variable. So cardinality is the number of labels that you have in a categorical column. So same code he has used for where variable in categorical. Categorical is nothing but a list of categorical column names. Then for every column, it has listed unique. So date contains 3,436 unique date values, and location contains 49 labels. Means we have data for 49 locations. We have the data for 49 locations. We have the data. Again, it is nothing but exploratory data analysis. Date data type, it is checking the date data type. We already know it is an object. So with this command, you can check the data type of any column. So it is coming out as object. Then it is converting. See, I told you date, you have to convert into date time. So date time, this is date time column. This is date time column. With this command, we are converting into date time variable. We are converting into a date time variable. Below, what we are doing, date time variable means it will have year. So with date.dt.year, we are extracting year. So see, year is extracted, and we have just printed the head. So these are this is first 5 rows. Then same thing we are doing month. We are extracting month out of date by applying dt.month. So month is a number. 12 means December. So again, first 5 rows. Then we are extracting day, dt.day. Then head, find 5 days. So days will be the weeks of the day, 1 to 7. So 1 to 7, first day to 7th day, Monday to Sunday. Then again it is taking df.info. Why he has taken it here again? He took it previously also, right? Why he has taken it again? Because we don't want to scroll back up to up and see what was there. So he did once again here. So we do it many times. So we are done. Then we have extracted all year, month, and day. We have extracted. So we don't need date column. So we have dropped it. Again, df.head. We have seen head just to check how many columns. So see, these 3 columns we have extracted. Year, month, and day we extracted. So 3 columns are added and 2 are dropped. One is risk_mm is dropped and 1 date is dropped. 2 are dropped and 3 are added. Like that, we can check. Further exploration of categorical variables. So what we are doing, categorical variable, just we are listing here, which are categorical variable. Just names are listed, nothing great. Then again we are checking once again we are repeating how many nulls are there. Then location. Now we are exploring a location variable. Location variable alone we are exploring. So how many we see how many levels are there? This we saw previously also. It has 49 locations. Then location unique names are exploring which unique names are there. So these are the unique county names, which unique village names or city names from which we have collected the data. Total 49 locations. Frequencies. So now value counts we are done again. These are all basic commands. So Canberra is repeated 3,418 times. Perth is a big city. It is repeated 3,119 times. Then Brisbane is also a bigger city in Australia, repeated 3,161 times. Then again, big city, I want to see anything. I'm not that much. Which Newcastle, Dartmoor, North Head, all are these small counties. See Melbourne. Melbourne is another well-known city. So we have around 2,435 rows. So like that we have counted. And then what we have done is for location we have converted get dummies. Get dummies, you understand what it is? Location, whatever numerical data, what these 49 locations were there. 49 locations were there. So we are converting into dummy levels. So for each of these counties, one column will be added. You see. So now we have done drop first true. We have dropped one of them. So 48 columns will be created. So these are the 48 columns you can see created, one for each county. So you understand one-hot encoding? Anybody any problem in one-hot encoding? I'll take a minute break. Anybody any problem in one-hot encoding? Madams, Ravi sir, guest student, one-hot encoding, you are familiar? Ashwini madam, are you familiar with one-hot encoding?
Sir, I don't know about this thing, but I will search after class for this.
Just read one-hot encoding.
Yes, sir, for sure.
Okay, so why we are doing this one-hot encoding? Because machine learning cannot take these location names. They always want data in numerics. Okay.
Yes, okay.
So we are converting them into numeric columns. So
Okay,
you go home and read about one-hot encoding and why we do it.
Sure. Yes,
okay.
Sure.
So that's what we have done, means we have converted categorical column into. So you should know that why we had just one column location in which 49 variable, 49 city names were there. So for each city, why one column is added, that you should know. Okay. For each city, one column is added, you see. So you should know that reason once you go home. Then wind gust direction, then 17 levels are there. Unique 17 directions. It has in our Hindu Shastras, we say that 32 directions are there, right? We have listed around 32 directions in our Hindu Shastras. So these weather people also have named 17 different directions. So I think they must maybe having more directions, I think, which are named actually. Like that, you can have every angle is a infinite is a direction, right? So you can have infinite number of direction in a circular compass. This is a compass. You see, this is a compass. This is a compass, right? This is a compass. So in this compass, each angle is a direction. So you can have hundreds of directions like this, but all the major directions are named. So our Hindu Shastras count is at 32. So I think, see, these people also have more. So they are telling 17 different directions. 17 different directions. Then it has done value count on it, means counted to the frequency. Waste is repeating 9,780 times. Decreasing order it has listed. Then again, same thing is done. Get dummies. So for 17 directions, 17 columns, for 17 directions, 16 more columns will be introduced. See, for one column each for each direction. For 17 columns, 16 for 17 directions, 16 columns are introduced. Then wind gust direction, and this what we did. Then why again it has done some number of ones. A number of ones it has summed up, nothing great. So
No. So, sir, in the different labels, different values for wind direction, there are some rows which are having none values, NA and none, not a data not available.
No, sir, it is not none. You see, it is what it is. Sum the number of ones. Listen. Sum the number of ones per problem, per Boolean variable over the rows of the data set. It will tell us how many observations we have in each category. See, so you see the code. Dot sum it has done. That means all the ones only it has counted. It is same thing as value count.
I understand, sir, correct. But before that, if you look at the prior to that, so if you look at that unique value count, unique values, right? So apart from the 17 directions, apart from the 16 directions, there is a value called NAN. That is, there are some rows which doesn't have the NA.
Where is NAN? Where is NAN? Yeah, here.
Here.
Yeah.
So he has to delete that. So that is why he said drop all the rows which are having NA values is equal to true.
Where is that?
That is what is that code? Yeah, dummy underscore NA is equal to true.
Dummy underscore NA equal to true. So what you say it has done? Okay.
So, correct.
Get dummies, dummy underscore NA equal to dummy underscore NA equal to. I'm not sure what this code is doing, but yeah, it is doing something related to null only. But as of now, I'm not sure what this is a column name, right? Dummy underscore NA.
No, it's basically ignoring the values.
It is ignoring it. Okay.
I'll give more information that too.
Yeah, so let us assume for now that this piece of code, whatever I have highlighted, ignores the dummy value because it makes some sense to ignore dummy column, right? So for now, let us assume that this particular piece of code dummy underscore NA equal to true is ignoring the dummy column, as Ravi says. So for now, let us assume that we'll go ahead because it doesn't make much difference. And otherwise, what we are doing is once we have counted, number of ones we have counted row wise. X is equal to 0 means row wise. So for each column we have counted once. So see, it is written now. It will tell us how many observations we have for each category. So we are counting number of ones. That's how it will give you how many observations we have in each category, right?
Yeah. Shailendra sir. 1 minute. I just checked the help logs, the manuals. So dummy underscore NA, basically, it will not drop the rows with NA values. It will treat it as a separate column.
What? So how it will treat it?
So basically, if you specify that dummy underscore NA is equal to true, false, it will drop all the rows that are having NAN values.
Okay.
But by specifying dummy underscore NA is equal to true, we are retaining that NAN values in the data set. We are not dropping those values.
Okay.
Those rows.
Okay. So thanks for adding that. And then And then so then another column, wind, direction 9 AM, total 17 levels are there. Unique levels are again 17. Value counts it is done. Then see, same thing it is doing. Get dummies it is doing for another column. Wind direction 9 AM. And same thing it is doing same thing. and dummy it is taking dummy in equal to true as Ravi said, and dot head. Okay. So same thing, get dummies for another column. Then next we go, it is counting the sum of number of counting this once. So we are getting how many observations we have for each category. Then we have another column, wind direction at 3 p.m. Then again 17 levels, 17 unique how many? Unique values, these are the unique 17 unique levels. So these are 17 unique levels are all repetition only for different column. Value count we have done different directions. The same code repeated, we are doing converting wind direction 3 a.m. We are converting wind direction 3 a.m. into dummy 1-hot encoding. We are doing same thing, same code. Next it will count same counting. Then train today, explore train today variable. So train today has 3 labels, yes, no, and NAN. Yes, no, and NAN means not a number. Yes, no, and NAN. So rain today. So yeah, rain today, either it rain today or it didn't rain today. Only 2 things will be there. No entry means NAN means they have not entered anything for that. Value count, yes, how much? No, how much? 1,09,332, no. Yes means 31,455. So this, then here converted same thing into dummies. Rain today is converted into dummies. And see, get dummy equal to true. So get dummy is converted into equal to true means it is NaN also is kept as a column. NaN is also kept as, so wherever NaN will be there, this 0 will be there, this value will be 1. In the NaN column, wherever we are having a null row with null, that time NaN will have value 1. Correct, na, Ravi sir?
Yes, sir. You're right, sir.
Yeah, so where, see, in this rain today column, listen, in this rain today column, whichever row we have a null value, for that NaN will have 1. So it is indicating that 1 indicates that which row in the rain today column is done. And why no is not listed? Because we have told drop today equal to true. Drop first equal to 2 we have done. Drop first equal to true we have done. So in yes itself, 0 means not rained, 1 means it rained. So yes itself we are using for 0 and 1. If we don't list this, drop first equal to true. If we don't give this option, then there will be one more column added. No. Yes, there is one column, then another column no will be there, and there is another column NaN will be there. So total 3 columns will be listed. So right now we have given an option, drop first equal to true. That means it has used only one yes column only, it has used to indicate both yes and no. So 0 means no and 1 means yes in the yes column itself. This is understood, I think. Okay. So get dummies, again it has done the same thing, yes. Then explore numerical variables. Now we have come to numerical variables. So we are listing how many numerical variables we have. So this code listed data type is not equal to O. See, previously to detect categorical variables, what we said, data type is equal to O. But data type not equal to O means numerical variable, right? So we have total 19 numerical variables. All names are given here. We have for data type numerical, we have printed the head. So see, there are a lot of NaN values are there. So we have printed head, summary of numerical variables. So it is listed. Then we have now we want to check in numerical variables how many nulls we have. Same line of same piece of code is null sum. Will tell you which numerical column has how many nulls. So mean temperature is having 637 null values. Rainfall is having 1,406 null values. Evaporation is having 60,843 null values. So that is the meaning of this code. Simple. We have these 3 columns, year, month, and day, with no null value. Why it is no null value? Because I think in their database also, when they are updating a row, their database, their code is also automatically inserting the date and time. On which date and time this particular observation was taken. So that is automatically taken. That's why we don't have anything in year, month, and day. We don't have anything. So in most of such data sets, when we create the data set itself, while creating the row itself, we always mention row and date and time. When we create that row, when we add any new row in the data set, that time itself we mention date and time. So that's why generally date columns are not null. Okay, so these are no nulls. 16 numerical columns containing missing values, right? Total 19 columns. We had total 19 columns. See here, 19 columns. 19 columns. Yeah, we have 19 numerical variables. Total 19 numerical variables. And these 3 columns, year, month, and day, are not having any null values. So total 16 are having with null values. So what we are doing? We are just doing describe. The dot describe is another command. So the command is only this much. Command is only this much, which I have highlighted. Df numerical column dot describe. This is the only command. What we are doing it? We are rounding off to all the numerical values. We are rounding up to two decimal places, and we are printing it. Even if you give only this command. And don't give any print. If you give this command only this command which I have listed here, you have to put in. This command also, if you give this command, only this command, you don't need to write any print. You don't need to write, the same output will come, because it will automatically print it. And you should try it out. Okay, so I am commenting it right now. So once you try at home, you just try it out. So all the columns are listed. See, rows are folded up because we have more number of columns. We cannot get in a single row. Okay, then we are doing, I want to take a minute break here. And so I think I would also like to have some water and all. So give a minute or two break. And now we are coming to exploratory data analysis using plots. So far, we have done all elementary exploratory data analysis is over. So now we are doing with the help of plots. So just take a 2-minute break or something.